Okay, I think we'll get going shortly with our next speaker. Really? Okay. Okay, it's my pleasure to introduce our next speaker who comes to us from the Canadian Wildlife Health Cooperative. It's Dr. Jane Parmley, who will be talking about avian influenza and the potential role of wild birds.
Okay, thanks, Andrea. And just before I get started, I do want to draw your attention that there are 2 question marks, not just one at the end of my title. And so I hope nobody has any illusions that I'm actually going to answer this in any definitive way. But hopefully over the next few minutes we can have a general conversation about what the potential role of wild birds in avian influenza, particularly in the current situation in North America, is. That won't do that way. And just before I get into the current story, I just wanted to introduce everyone to avian influenza viruses, and I'm sure this is familiar to most of you. The virus is made up of 8 different gene segments, and we typically name the viruses based on 2 of them, the hemagglutinin gene and the neuraminidase gene. So when we talk about H5N1 or H5N8 or H5N2, those are referring to that hemagglutinin gene and that neuraminidase gene. There are 2 sort of distinct lineages along which these viruses have evolved, one in the Americas and then another one in the Eurasian continent. And because of limited mixing in the past anyway, and continuing on today, these viruses have evolved somewhat separately and along different lines. We also characterize these viruses based on their pathogenicity to chickens. So they're low pathogenicity, causing relatively mild disease in chickens, and then the high pathogenicity viruses that cause more severe disease and are often associated with really high levels of mortality in domestic chickens. And to date, it's just those H5 and H7 viruses that have been associated with viruses causing highly pathogenic or that cause very serious mortality in chickens. And then finally, waterfowl, ducks, geese, swans, and other shorebirds are considered broadly around the world to be the natural reservoirs of the low-path strains of avian influenza, and their role as reservoirs for high-path strains is still being debated around the world. And I am going to focus much of this talk on the current situation in North America, but it does relate back to what happened in China about just over 15 years ago. So I'm going to start there as an introduction, and then we'll move through until the present day situation. So in 1996, there was a sick goose in China. It sounds like the start of a really bad joke, but it's not. So there's a sick goose in China. And from this goose, an H5N1 virus was isolated. And that probably would have gone sort of undetected, unrecognized, or unnoted anyway. But there was an outbreak the following year in Hong Kong that affected both poultry and then ultimately people as well. And this was the first time that these avian influenza viruses had been associated with disease in people. And during that 1997 outbreak, 18 people were sick, and 6 of those individuals died of the infection. I'm not going to spend much time talking about human cases. We're going to focus on birds, but just recognize that this H5N1 virus is still associated with human deaths and disease in many countries around the world. These viruses evolve quickly, and their behavior changes a lot. And as part of this outbreak in Hong Kong, we learned a lot about these viruses. And one of the things that was noted is that during this outbreak, the transmission was directly from chickens to people. And it didn't go through an intermediate host, something like a pig, which was traditionally how avian influenza viruses were thought to affect people. Finally, in order to control this outbreak in Hong Kong, all of the poultry in Hong Kong were slaughtered. There was about 1.5 million birds, and live poultry imports were banned from China for a short period of time. And that seemed to kind of control the outbreak at that moment. But as we all know, it was not the end of this H5N1 virus. And then in late 2003, moving on into 2004, the same virus, or very similar virus anyway, was associated with outbreaks in poultry in several different countries in Asia. And that, as that was going on and more people were getting infected, this virus was getting a lot of attention. But really what got the attention of people in the wild bird community was this outbreak at Qinghai Lake in China, which was sort of the first outbreak amongst wild birds that was associated with mortality. And it was an investigation into that outbreak that it was first suggested that wild birds could in fact be moving this virus around the world. Subsequent to that outbreak, there were detections in poultry and wild birds in Russia, Kazakhstan, and then moving westward into Turkey, Romania, Ukraine, Croatia, and Kuwait in the Middle East as well. And we keep going forward in 2006. With new outbreaks recognized in the Middle East, in poultry, in Africa in poultry, in South Asia in poultry, and then ultimately in Europe in poultry as well. And the same virus as H5N1 was detected in wild birds in several different countries around the world. So our understanding and how we approached avian influenza viruses changed a lot over this 2-year period. I'm going to stop there in terms of sort of the history. It didn't go away. It continues to cause disease in birds and people. But sort of the new understanding, the changes in the virus behavior kind of ended at that point for a little while anyway. And that brings us, before I do that, I just wanted to comment. The reason I wanted to start here, and this slide was here just to remind me to do this, is that these viruses change a lot. They evolve quickly, their behavior changes. But what has remained particularly stable in these Asian H5 viruses in particular is that H5 piece. So it seems to have stayed relatively stable, and that conveniently provides us with a bit of a baseline in which to compare and categorize all of the other H5 Eurasian viruses that are out there. So that 2005-2006 spread around the world was associated with this clade 2.2 here somewhere. And the current situation in North America can be linked back to that original virus in that sick goose in China. And it's this new clade that's not on this map, and it's this clade 2.3.4.4. So coming back to what's going on currently, or relatively currently, I think my information's up to about last week. But if we think back about 18 months, there was this highly pathogenic Eurasian lineage H5N8, so we're no longer talking about H5N1, that had been identified in China. And then in early 2014, that same virus was associated with outbreaks in poultry in South Korea, and then subsequently in China and Japan as well. And an investigation into those outbreaks sort of hypothesized that this virus was being spread to those areas and infecting poultry and coming from wild birds. As those wild birds continued on their northward migration that spring, they landed up in northern Russia and Siberia, up here. And at that point, this H5N8 virus is believed to have spread into 3 sort of distinct subgroups: the intercontinental group A1, group A2, and group A3. Group A1 seemed to move, possibly with migratory birds, into Europe. Group A2, with migratory birds presumably into North America. And that group A3 seemed to stay relatively consistent in that sort of Asian Pacific corridor. Interestingly, just this past winter, all 3 of those different subgroups of this H5N8 virus were identified in birds in Japan again. So it seems that it sort of spread out and either came back or spread out and also remained in place. What happened there remains to be determined. And that brings us to the situation in North America. And the current situation going on right now in the Midwest is associated with H5N2. And I will get to that, I promise, but let's finish the H5N8 story first. So this is a wholly Eurasian virus. It's highly pathogenic. And it was first detected in Washington State in a captive gyrfalcon in December of 2014. In that same month, it was further identified in Oregon, Idaho, and California in backyard poultry, wild ducks, and a few more captive birds. Then in January and February, Further identifications were made in Nevada and Utah, and a single American widgeon duck was identified as carrying this virus from British Columbia. As it turns out, that duck was actually hunted in the fall, but was not tested until February. Okay? So that was sort of where this H5N8 story ended until about 2 weeks ago, when it showed up in Indiana in a backyard poultry flock. And to date, I think that's the only identification of H5N8 highly pathogenic Eurasian strain outside of the Pacific Northwest, and it remains the only case to date, unless there's been new things in the last day or two. So then that brings us to the H5N2. And this virus is also highly pathogenic to chickens, but it is believed to be a reassortment of that H5N8 Eurasian strain with a low pathogenicity H5N2 that was presumably circulating in wild birds. And this was identified in British Columbia in commercial poultry in December of 2014, and it's what really got started in terms of the enhanced surveillance, both in the United States and Canada. Subsequent to that identification in BC, it was further identified in Washington and Oregon, not only in commercial poultry, but also backyard poultry and wild birds. Then in January and February, there were further identifications in Idaho, and it seemed to be similar to the H5N8 story, kind of limited to the Pacific Northwest, until late February, when a commercial turkey flock in Minnesota tested positive for this same virus. In March and April, that virus spread and was detected in numerous other states, including the province of Ontario, in wild birds, captive wild birds, backyard poultry, and commercial poultry. And as of last week, there are still active infections going on and being identified in 6 states in the US. In the Ontario situation, 3 farms total have tested positive. There have been no new detections since the end of April. And that is despite some ongoing testing. Just finally, to wrap up the story, so there's H5N8 circulating, there's H5N2 circulating, there are also 4 identifications of H5N1, highly pathogenic strains of virus. These are not the same H5N1 viruses that cause disease in people and chickens in other parts of the world, but there was a single identification of H5N1 in backyard poultry in BC in February, and then 3 wild birds tested positive in Washington State prior to that time. So that's kind of the situation. That's a really fast sort of overview of what's happened in the past 15 years. But how is this virus moving? If you think back to those maps, both the H5N8 virus and the H5N2 virus seem to make big leaps across the North American continent this past winter. Is that because of migratory birds? That west-east movement is not a typical pathway of ducks. It certainly is not something that routinely happens in the middle of winter. At the time of the outbreak in Minnesota, it was probably -30 with very little open water. And so what else could possibly explain that? In other parts of the world, trade of poultry and poultry products has been implicated, as well as trade in wild or captive wild animals. And really, I think in terms of what the role of wild birds is in these big distance movements anyway, probably depends on the context and where you are. So you have to consider important climate, and agricultural differences in where the regions where outbreaks occur. So you've got differences in tropical and temperate regions because the virus survives differently in warm environments as opposed to cold environments. It really likes being cold. There are differences in northern versus southern countries, and probably most importantly, in terms of movement of birds in particular, but there are really big differences in the interface between poultry and wild birds, between extensive and intensive agricultural practices. And that's where I find the big question really lies, is how does this virus move little distances? How does it get from a wild bird that may be sitting on a wetland down the street into a poultry barn? How does that virus, what are the exposure pathways that are connecting those wild birds and the domestic poultry? How does the pathogen move at that interface? In Canada, we've done a lot of surveillance. We have over 10 years of studies that have been done. We've tested over 50,000 birds. Several of them have tested positive. And until this year, none of them had tested positive for any highly pathogenic strains of the virus or any Eurasian strains of the virus. To date, in 2015, we have tested over 600 dead birds, I think now. Just 2 of them have tested positive. None of them in Ontario have tested positive for high path or Eurasian viruses. And the only one that remains positive is that single duck that was tested in February from British Columbia. So what have we gained from 10 years of surveillance? We've learned a heck of a lot about the virus ecology. We know these viruses are particularly common. We know that prevalence and subtypes vary by species, over time, and across space. And so we've learned a lot about the virus itself. We've also successfully established some really important connections between the labs, wildlife experts, agriculture and the poultry industry, and public health people that I think has been really strong in terms of maintaining interest and ongoing activity in this area. And so when we think about the surveillance program, what we've tried to do, we've generally sort of identified 3 different goals: to meet international objectives, to improve our understanding of avian influenza ecology, and to provide early warning. And I would argue we've done really well at the first 2 and not so well at the third one, which is really how we argue and sell our surveillance programs generally. But if that is truly our desired outcome, to do surveillance in wild birds, to provide early warning about the virus and the risk to poultry, then we probably need some more information. We need to know more about where and how wild birds and domestic poultry intersect. And we need to know what information would impact risk reduction and biosecurity planning and practices on the farm. And to do that, we probably need to carry out some sort of needs assessment. And once the needs are identified, establish some sort of threshold in which action will be taken. There are several options to enhance our early warning. We could take a risk-based approach and identify high-risk areas for sampling. We could focus our attention more around primary poultry production areas. We could better determine where and when to sample and what species to target. And we should also probably investigate new sampling types. We can look at collecting environmental samples, remote sensing or satellite imagery to focus and identify high-risk areas, and probably all sorts of other things as well. And so I'll end there with just one sort of push or promotion for surveillance generally. Surveillance takes a lot of time. It's not always particularly exciting. But in order to have a strong surveillance program, we need to have ongoing support and continued activity in these areas. That helps us build cooperation and trust with many partners, and it really provides a framework on which we can have surge capacity and identify new research platforms into the future. And I see Andrea there, so I will finish with that.
We have a few minutes for questions. Okay, thank you.